Good afternoon. I agree. I'm happy to see people here. A lot of times when the word IT is listed in a title, it seems to be much scarce. So I'm going to talk specifically, though, here about DICOM and IHE relative to radiation dose. So I think most of us already understand that DICOM is an open standard. It actually is developed to try to build a standard so we can have communications between devices. So utilizing DICOM, you can ensure that devices can communicate information between them. The DICOM itself, I'll just go over a review, is governed by a DICOM Standards Committee, which is made up of manufacturers, users, and actually just members of interest. It has two chairs, one that is a user chair and one that is a manufacturer's chair. The work, though, in DICOM is done through working groups, and these working groups, there currently are 29 of these working groups, and if you look at the titles, you'll see that they have things that you might expect. They are modality-based, but they're also in connectivity-based, and it's the experts in the area, both users and manufacturers, that interact to try to build the standard. The actual standard is built by these working groups developing work items. Anybody can propose a work item to the DICOM Standards Committee. It can be a general public individual, a manufacturer, or a user. When changes are made then, when a work item is approved, depending on if it's something added to the standard, it would be considered a supplement. If it is something that is already in the standard that needs to be enhanced and or changed, it would be considered a correction or change proposal. If we actually go to the website and look at the DICOM standard itself, you'll see that the DICOM standard is published on a semi-routine basis, and I'll give you a little more detail of that. Generally, whatever is published, in this case you see this is the most recent publication, December 14th, 2013, is when it was updated, but the standard, if you look farther down, was actually published in 2011. So the standard that's published in 2011, you can download it, and the manufacturers would download it, and that is the standard. But any additional supplements or change proposals that have happened and have been approved since that date are also part of the standard. So you have to actually search through all of them. And since 2011, December, when it was actually published, there have been 11 supplements, these are the supplements in front of you, that have been approved, and they're in final text. They are part of the standard. And there's been 187 change proposals. So you see there's a lot of things going on, and to keep up to date what's in the standard is actually somewhat of a daunting process. The next version of it is already in the works. It's supposed to be published in April of 2014. And it's going to be now published in a new format. It actually will still be in PDF for us to easily digest it, but it's going to be in HTML format such that it's going to be much more simpler for them to maintain it. And the current concept is that it will actually be updated quarterly, not every 3 years, but maybe 4 times a year. Just go over again to make sure everybody's on the same page as me. Basically, the DICOM standard defines both primarily information objects. It does apply, as I mentioned before, it does do about communication standards, et cetera, but most of us are concerned with these object definitions, and there can be image objects and non-image objects. In the image objects, these are things like what is the CT object, what is the MRI object, and we should understand already that there are enhanced and non-enhanced versions of objects, so you can get the enhanced version of a CT object and the non-enhanced. And the non-image objects are things such as structured reports, waveforms, registration algorithms, et cetera. Looking at the standard, sometimes it's daunting. The standard is broken up into parts, and currently there are 20 parts to the standard. If you want to find something, you need to know where to look. And so I'm just going to briefly go through some of this, but I'm going to try to highlight some of the areas that maybe are changing relative to radiation dose. So the information object definitions are in what's called Part 3.3. But of interest also might be is the service class specifications, and I'll talk about why that might be important to look there. The content mapping resource section is going to be very important when we start talking about radiation dose structured reports. And last, there is something in their Part 17 that's called the explanatory information part. Many times when change proposals and supplements are developed, the working groups will add stuff to this that is examples. So you're not going to find examples inside the DICOM standards other than in Part 17. There was a new Part 20 just added in 2013 that is transforming DICOM to HL7. So this is something hopefully I'm just reviewing. Everybody has seen a DICOM standard, and you know that there are tags for attributes, and they are listed in tables inside the DICOM standard. And these tags will have descriptions, and they'll have types listed to them, whether or not they are mandatory, whether they are optional, and then whether they're conditional. So, example, some things are conditional only if they're known, then they might be mandatory, etc. These modules then are reproduced then in macros. The idea behind doing it this way, and this is where some people get confused, is they'll look at a DICOM object, and this is the digital X-ray list of modules. The macro says, just go to, if you want the patient module, they're not going to repeat it in Part 13. They're going to tell you to go to the Annex C.7.1.1, and that's where you'll get it. And it just gets used over and over and over again because the patient information is the same, whether it's a CT, digital X-ray, MRI. And so as opposed to repeating it, they basically say, just go look for that module, and we're going to use it. And in fact, it says the usage in this case is mandatory. You have to use it. So we know then that there's modules and macros for these image objects, and if we look at the data, basically dump out, most systems that can dump out what we would call the metadata. It's not usually all header information, it's just relevant header information, but almost all PACS systems and RIS systems can do this. If we look at this data, we say, okay, this is something I see, and here, for example, is tag 860, which is the modality data element. It's a known tag, and in this case, it says it's a DX, it's a digital X-ray. So I'm hoping that's all review. We've all at least seen that, heard that, and been through it. Now I just want to go on some nuances that I've found in the past people get confused about. If we now look into the SOP classes in Part 4, though, we see that, well, wait a minute now, that last object said it was a DX object, digital X-ray. Well, is it a digital X-ray for presentation or for processing? You see, mammography has the same thing, and in fact, mammography just added a supplement for tomosynthesis. So now there's a tomosynthesis mammography object in the DICOM standard. If you're only looking at the modality data element, though, it's going to say MG. It's not some TM for tomosynthesis mammography, etc. In fact, if you look down at things like MRI, it even has spectroscopy in there, which would be a non-image object. But the modality data element is just going to be MR. So you need to understand, where do I look to say, well, wait a minute, what part of the standard do I need to determine what my modality is? So let's go back to that example here. And yeah, we saw that that was a DX object. But what is it? Well, it's actually down in tag 2.2, which says that the storage SOP class for this is the digital X-ray for presentation. So now when I go back to the standard, based on that storage SOP class, that's where I'm going to go look to find out what should be in the header, what's mandatory, what's not mandatory, etc. It's the digital X-ray for presentation. That's the most important thing for us to understand. How do I know what's being sent or what should be sent? Well, that's in your DICOM conformance statement from the manufacturer. This is just an example pulled off from a manufacturer, and they're listing, for example, here all the different formats that they support. They are claiming they are in compliance with these, and so you can go to their conformance statement and find this, and then if you look at the MRI, it says they store both the enhanced and the non-enhanced DICOM object. Notice that the UID, though, is going to differentiate. So in that SOP class, you're going to look for at the ending, the 1.1.4.1. If it has that extra 1 on the end, it's the enhanced MRI that's being stored. Which one is being done? Because this manufacturer says, I support both. That depends on how your system's set up. And in fact, you can change that. You as the user, it's your piece of equipment. Since the manufacturer supports both, you can send either to your storage system, your processing computers, etc. Understand, the DICOM standard says there will be a conformance statement for, in this case, the MRI modality. You're also going to have a conformance statement for your PACS system. So even though your modality says, I conform to the enhanced MRI object, you have to look at the PACS conformance statement. It may not. It may say, I don't know what that object is. In that case, you wouldn't want to set up that it's sending the enhanced object. To confuse or not confused, this is that example for an MRI here. The modality is an MRI. The storage class is the standard, non-enhanced. But what's all this stuff down here in the header? This is all enhanced information. All of it down there that I list there, obviously, you don't have to worry about seeing it, what it is. Trust me that this is enhanced information, but they're only storing, and their conformance says, based on an SOP class, they're only storing the standard. But it's all there. And many, many, many vendors do this. They basically will say, well, I can fill the header with all this enhanced information as an example, albeit I'm going to tell you that I'm only sending the standard for storage. Because of this, if something's missing in that enhanced data, they are actually still conforming with the DICOM standard, because according to your standard SOP class that they're stored here, they're not actually storing that information. They're just kind of giving it to you as an extra. When we start talking about non-image objects, now I think we're going to start talking things that people maybe are not as familiar with. You've heard of these things. Structured reports is what I'm going to use as the example because it's the most relevant to what we need to deal with in radiation safety and in talking about radiation dose. The structure of these structured reports is in a similar manner to the modules and macros of an image object, but we don't call them macros now and modules, we call them templates. And so you'll find templates that are built into all structured report that are going to give you the information about what's in the structured report. And when you dump one of these, you're going to see this listing of a whole bunch of information. And I'm not showing you this so you can try to read it, but I'm going to tell you right now that you'll see in any structured report, the data element tags are the same tags repeated over and over and over and over again. And in fact, these tags, these three specifically that I'm pointing to, are the tag for a code value, a tag for a code description, and a tag for a code meaning. And in this example, we have, this is the dose area product, and so the code value, again, I know you don't see this, is actually gray meters squared. The description is, again, grays meters squared, and the actual value is written down here, is an enumerated value, etc. This one is the total dose at the reference point. So these tags are identical. They're just the code meanings. You have to look at what is the code meaning. This is now gray, not like DAP meter. This is just gray because it's a total dose. So the key here is everything you just learned about tags and what's mandatory and what's not and where is a tag, you're somewhat going to throw out the door because the structured reports are not revolving around what is the tag defined as. It's what is the template and what is required in the template. And the template's going to require just a bunch of coded information. And the template will tell you what the coded information is. They'll all have the exact same of these 3 tags, 4 tags. So what are in these templates? Well, you're going to, if we specifically talk about the radiation dose structure report, it was developed in 2005, and it really only had 3 templates. It had this observer context that is sort of like the patient information and the operator information. So that template ID is 1002, and it's in almost all structured reports. What it did is it put in these 2, the irradiation event per irradiation event and the accumulated X-ray dose. I want to note here that this was developed, the radiation dose structure report is the exposure and dose characteristics of the X-ray machine. It's not for therapeutic. There is actually a separate image object, an IOD for therapy. And it's the output information, not patient dose. And we'll talk about that in more detail now. So just to go over what these are, 10,001 actually is for a projection radiography, and it was set up for an interventional system originally, such that if you had a biplane, you'd get 2 of these every time each biplane was irradiated, and it would record all the irradiation data for every time the pedal was pressed, and then it would add them up and put them in the accumulated over time. So when you're done, you would have each individual irradiation event, all the information, and just one place to look for the total. In 2007, they did a change proposal, a change proposal, which also became the idea of adding this supplement for, it actually became a supplement to say, let's put mammography in there. So now what happened is, it wasn't just for a plain radiograph, now it says, oh, we might have mammography. So because of this, they changed it all. So people that were looking at radiation dose structure reports prior to 2007 may have some structural differences than what you're going to see since then, because all of this stuff down here that was specific to the accumulated X-ray dose for a single plane has now been removed, and it's been changed such that you have accumulated if it's a projection X-ray machine, or a different template if it's mammography. Well, actually, now allowed the radiation dose structure report to be improved even more, and as recent as 2012, now notice this says approved in 2012, that means you won't find it in the current standard. You got to look in the change proposals when this was done, and this happened to be change proposal number 1077, and they are numeric in nature, so you know how many are out there. This added the idea that I can look at, instead of just accumulated dose for a projection X-ray system, like in a C-arm fluoroscopy, but I also have now mammography systems. Then I have a cassette-based, CR reader-based, or integrated systems. These are systems that now are directly connected to the generator. The differences between these is if it's an integrated system, you should have things like what is the orientation, what is the KV, what is the source, etc. You should have a lot more information if it's integrated than if it's not. And so there now is a place to put all of that information about your detector in there. This does have a place to put the detector exposure, in fact. The exposure index, the IEC exposure indices can be put in there. CT added to this in 2007, and so they have this irradiation event every time the system irradiates, and then the accumulated if you're actually going to do multiple series on a single patient. This was added in addition to that, the size-specific dose index and iterative reconstruction methods were added in 2001. I will tell you, the iterative reconstruction method is a single line in the dose structure that says back projection or iterative. It doesn't actually give you any information about what type of iterative is statistical, is it full modeling, what is the parameters of it. Unfortunately, that's not in there. Change proposal to come, I'm sure, to add it. They did add in 2009 the concept of the overranging, the scan length, such that that can be included in the dose. So that is in there. And they added also in 2010, which is now in the standard because it was done in 2010, the National Electrical Mechanical Association dose check values such that the alert values can be stored in the radiation dose structured report. And then for the specific patient, if you set your procedure up, you can estimate what the actual dose is going to be, and if those fall outside the dose alert and or if the patient exposure is outside, the reason why you continued with the study. So that information is all in the new CT radiation dose structured report. Just as an aside, because we may have a stray radiologist in here. I know Peter's at least one, so we have an N of 1 of radiologists in here. There is a radiation dose structure report for a radiologist, and in fact, it's actually building on the structure report that was built as a basic structure report in the very beginning. The concept of structure reports in radiologists. I think most of us that listen to or hear structure report now, what we're thinking about is, oh, that's the dictated report with structure from the ultrasound measurements or structure from the machine getting put into my dictated report. Well, that's not exactly what's happening here. Theoretically, it could, but most dictation systems and most RIS systems, radiology information systems, that are storing the report are not using the DICOM structure for the structured report, but they could. And because of that, into the structured report, they've added the radiation information. So the radiologist has a place to put simple things like, what's the pregnancy status? what is the radiation exposure, what is the radiopharmaceutical delivered, et cetera. There's supplements that are being developed as we speak. Several of them are in final text. That means what gets approved as final text will be the final standard. Letter ballot means they're being voted on right now. And public comment means they're being reviewed by the public. And when it says public comment, these actually are full public comment. Somebody on the street could just pick up and send in an email that says, hey, I read this thing and I don't think I agree with it. And the DICOM working group would have to respond to that individual. The only one that's of interest to us from a dose perspective is the Radiopharmaceutical Administration Radiation Dose Reporting. That report is for nuclear medicine and PET imaging. It added 5 new templates, and it's basically adding, and in fact it is adding now because there was a dispute about this, it's really just adding what was the administered activity and what was the information at the time of administration. This is out for letter ballot right now, and in fact, as of March 7th, the voting has ended. So I don't know whether it got voted for approval or not, but when I get back to work on Monday, I probably will know if it's been approved or not. Okay, so that's what's already there. What's the next phase? The next phase is basically Working Group 28 that Annalisa and I co-chair is called Physics Strategy. And we were brought in as users to the DICOM Standards Committee basically to try to assist where you didn't find specific areas and modalities where things needed to be put. And one of those things is the patient radiation dose structured report. The patient radiation dose structure report is something that we as physicists do all the time. Right now, in this little graphic I'm going to show you, if it has a little white scroll, that's something that's already in the standard. You have an X-ray system, a CT system, it has a radiation dose structured report, and it has the IOD with the image. We as physicists then may have to take that information to a fetal calculation or something else. If we're dealing with CT and other things, we may say, well, I'm going to use a patient model, and I'm going to use one of these systems out there that uses a Monte Carlo of a patient model, and I'm going to estimate an organ dose. Well, there's nowhere to put that inside the standard right now, so we think we need that, and we're going to have to figure out how to get that in there. And a lot of stuff I'm talking about now, the next discussion is going to be exactly how to get some of this. I'm just going to talk to you about the format. In addition to that, we know that stuff you put in the beam is going to perhaps change the beam. Any type of patient positioning, the tabletop material might attenuate the beam, might cause scatter, is going to moderate what happens to the patient dose. I need that information. I need the model. There already is a registration. If we get this information and we get a model, we could probably register it with the patient image. And in fact, we may want to save that. I don't know. That's something that's under discussion right now. But clearly after all, and there's one other thing. We clearly need to know everything that's in there, right? We need to know about this absorption, table dimensions, et cetera. Taking all of this data now, we're going to make a patient radiation dose structure report. I don't know if that's the acronym for it, but we're going to develop something. Then we're going to have to determine what's the output. Is that output going to be something like you would see a 2D map of the ISO dose curves? Is it going to be for skin mapping, some type of a surface map? We haven't developed that yet either. Maybe next year we could tell you more. And we're probably going to have to talk about what about the dose for the patient last week in a different study. And we're probably going to have to do some type of an accumulation. Okay, so that was very quickly what's coming next. I'm running out of time, so I'll move quickly. IHE now is a company that doesn't make standards. It actually says, how do you use standards? It's a forum for getting together and to say, how do we actually implement standards? And they basically will look at all organizations that develop standards, NEMA, IEC, ISO, HL7, and their job is to say, how do we make it all work? It's 638 members around the world that actually are involved in it. Similar to working groups, they have these domains. Radiology, you can see, is only one domain of what they deal with. And what they do is they develop these profiles, and the profiles then say, how do different pieces and different, what they call actors, utilize multiple standards and make it all come together to work? And just as a real quick, they do have a profile on radiation exposure monitoring. Basically, that says, we know we have all these radiation dose structured reports out there, but we need to somehow get them into an area where we can analyze them. And we may have to go to registries to register doses out there. There may be requirements from legal relative to whether it has to be done or not. And so they've already developed this patient radiation exposure monitoring profile that says how to use the pieces that are already available to you. This is what you end up seeing if you go into any of these profiles. The reason why I just mentioned this quickly is I would say most of us, even as physicists, are never going to get into these details because we actually don't need to know the details. Who needs to know the details are the manufacturers of each one of these actors. The modality needs to know it. The radiology information system needs to know it. Your dose monitoring software needs to know how to use this REM. But if they say they're in compliance with REM in IHE, now you can say, well, based on that, I can look at any one of these areas inside of it to say, wait a minute now, the communication between the image archive and the dose information system is not working. What's breaking down in your profile? And this is the conclusion? All you had to do was ask, Peter. So the conclusion is they test these through connectathons. They're held all over the world. And they actually have testing tools that are free for everybody to use. Again, I don't foresee physicists doing that, but it is out there and available. And there's the end, see?
Thank you. Okay.